Hello, everybody. This is Mr. Ainsworth, and we're going to get into another MRWC lesson, or activity, if you will, 3B1. Yes, and this is not exactly the 3B1 activity. I revised it a little bit. So if you guys are watching this from another campus, well, you just have to go with the flow and uh, go with the flow. Okay, so there we go. All right. The skills involved in here are obviously the same. We are trying to construct irrational numbers on the number line here and do it with only a compass and a straight edge. So let's get started here. We're going to need some tools. We're going to call them the compass and the straight edge, and we're going to do it the way the Greeks did, okay, 4,000 years ago, 2,000 years before Christ. And yeah, this stuff's old. So we're going to be using a compass and a straight edge only. And because of that, well, let's go ahead and grab one. Okay, so let's grab the compass. Okay, and there we go. And then we need a straight edge too. Now you'll see a ruler here. Okay, but the marked divisions on the ruler are not needed, and that's why we call it a straight edge. Okay, I don't. You can use a note card if you want. Okay, I don't care, or the side of your ID card or your license. I don't care what straight edge you have. You do not need a ruler. You just need a compass. Even a string would suffice, okay? So get something that can create arcs or circles, and you got a compass, and then get a straight edge for a ruler, okay? And so here we go. We're going to get into a couple cool constructions here where the only tools allowed are what's called a compass and a straight edge, okay? So let's talk about that. So compass and a straight edge. Those are the only things allowed. Now, keep in mind that I want you to number, or the number line must be labeled with all the numbers constructed and that are needed to locate the given irrational number. Now, irrational number in this case is square root of 8 minus 2. Now, to do this, you have to know what the square root of 8 is simplified. Okay, so we have to do a little arithmetic here first. Okay, so what is this equal to? Well, let's do it in the margin actually. So the square root of 8, all right, is equal to the square root of 4 times the square root of 2. Why? Because, well, 2 times 4 is 8. And the square root of a product equals the product of the roots. All right, so I'm allowed to square root the factors of 8, and I get 2 times root 2. Whoops. 2 times root 2. All right, or called 2 root 2. 2 rad 2. You can call it any way you like. Okay, just it's 2 root 2. And the reason why I need to do that is because we know how to construct root 2. So to construct anything bigger than root 2, like root 8 or root 18, you kind of want to simplify the numbers first. All right, so we'll do that. You always want to simplify the roots first. Yes, I'm writing all over my lesson. So simplify the roots first before you construct. Okay, so simplify first, and so I get a new expression here. So it's, woo, that's a little bit too thick here. Again, you gotta, there you go, you gotta know how to use the program. So why 3 root 2? That is wrong. Come on, Ainsworth, I'm getting a little crazy right now. Okay, so let's go back here. 2 root 2. So root 8 is 2 times the square root of 2 minus 2. And that, my friends, we can construct because we already know how to construct root 2. So constructing 2 root 2 is easy. And then minus 2, well, that's easy as well. I'll show you how to do it. All right, so let's get started here. By the way, it's kind of nice to know what this is equal to. So, we're going to use this right here, the handy dandy T84. You can do it. You can use whatever calculator you want, okay? But let's enter the square root of 8. Make sure you do it properly here. Make sure you end it with parentheses here. All right, and then minus 2. So root 8 is less than 3. It's like 2 point, I don't know, I'm estimating here. So I would estimate it like 2.8, 2.9, something like that. 2.8 maybe. I'm not quite sure. And then minus 2, it's positive. So I know it's positive, like 0.8, 0.9 or something like that. I don't know. So, oh, look at that. I was close. 0.8, 0.828. So 0.828. So it's definitely less than 1. So wherever we construct this, it better be less than 1 unit. So it's got to be between 0 and 1, and it's got to be close to 1 because 0.82 is close to 1. All right, so let's get right into the construction. I know where my end result must be. The question is, can we make that happen? All right, and of course we can. So here we go. So the first thing we're going to do is we're going to construct root 2 first. Okay, let me make a little note of that. Okay, we want to, let me see, we want to construct root 2 first. And I'm just going to go through this pretty quickly here because guess what? We already did that before, and you should already be good at that. So you want to construct root 2 first. All right, so what I'm going to do is I'm going to locate number 2 on the number line. Okay, so what I'm going to do is switch hands and adjust it. Now, on the computer here, I cannot get exactly to 1 unit. So notice this right here. I'm going to adjust it from 0 to 1. And if I can get close, notice right there I can get close, but I can't be exact. If I was doing this with paper and pencil, I could be. So just keep that in mind. All right, so go ahead and construct root 2. Oh, excuse me, 2. All right, so with a compass, and we're going to do this the way the Greeks did it. Okay, the distance between the pointer and the pencil is what's called the radius. All right, all right. Okay, so now, so let's label. And then again, I said number line must be labeled. Look at this. Number line must be labeled. So if you find 2, label it 2. If you guys don't label your number line, you're not going to get credit. So you just keep that in mind. And notice right here, there's a little error. All right, there, because I cannot be exact on the computer, believe it or not. And I know what you guys are thinking. Like, with a computer, you're always exact, and it's not the case. All right. There's only certain things I can do. There's limitations on the computer. So be more exact than I am, okay? All right, so now what I want to do is construct the perpendicular bisector between 0 and 2. So here we go. So at 1 here, or excuse me, at 0, I'm going to switch colors here. I'm going to adjust the radius a little bit more than halfway. You guys have, oop, that's too thick. You want your lines thin. All right, so make sure your pencil tip is sharp and make sure that your pencil tip is sharp and you're doing the things the right way. Okay, whoa, okay, didn't mean to do that. Don't change the radius, okay? Sorry. Okay, getting a little crazy here on the computer. It's my birthday, so hey, hey, what the heck? It's October 8th, and every October 8th is my birthday. I'm 53. Holy cow. Okay, I'm getting old. Okay, so that's probably why I'm a little bit crazy today. I'm acting a little bit different just because it's my birthday. All right, so now let's go ahead and draw the perpendicular bisector. Now to do that, you got to get this straight edge. Okay, and once you get your straight edge, you got to line up the points. And a lot of you guys are saying, "What points, Mr. Ainsley? What are you talking about? What points?" I'm talking about this point and this point right here. Okay, the points in red. All right, so go ahead and you guys already know this too because this is in a prior lesson, right? I already talked about how to construct the perpendicular bisector. All right, so here we go. Draw that perpendicular bisector. Not that thick though. I'm a little bit goofy today just because it's my birthday. All right, draw it really thin. You know what? Gotta draw it thin. I thought I picked the thin one. Okay, well that's good now. All right, so we have a perpendicular bisector going through 1. And what we need to do now is use this point, and this point. Let's call these point A, point B, point C. Connect A to B. All right, now to do that, all right, it requires your handy-dandy straight edge. So get your ruler, all right, your straight edge, your note card, your ID card, whatever you have, right? I mean, get creative, guys. Just get creative. All right, and go ahead and construct the segment from A to B. All right, so now we got our segment from A to B. And what do? We need to know what's going on. So let's do that. Let's talk about what's going on. Now, in my prior video, I talked about this triangle ABC. Now, any triangle that is isosceles, all right, always has the same ratio of sides. Ooh, what does that mean? All right, so what I'm saying is this. Okay, so what we're saying is that if this length is 1, whoa, that's a little bit too thick. Getting a little crazy. So right here, this side is length 1. 1, right? The distance between 0 and 1 is 1. All right, so the distance from A to C is 1. Now, because I used the radius from C to A and I rotated up to B, well, guess what? This is 1. All right, so it's an isosceles triangle. So isosceles. And A to C and C to B are both 1. All right, the question is, what is the hypotenuse? Now let me see. 1 squared plus 1 squared is equal to AB squared. 1 plus 1 is equal to AB squared. I already went through this in my prior lesson. 2 is equal to AB squared. So if you square root both sides, all right, I get the square root of 2 equal to AB. So this is my square root of 2. AB is equal to root 2. All right. Now, to get the square root of 2 on the number line, we're going to take our handy dandy straight edge. Excuse me, compass. Getting a little crazy. All right, and we're going to take our compass here, and we're going to adjust it from A to B. All right, so notice that I'm adjusting from A to B. All right, now, by the way, this is a video, right? So if I go too fast, or I'm too goofy, because it's my birthday, so I'm a little goofy today. I'm just trying to make it a little bit more fun. Then go ahead and pause and play the video. Rewind it, maybe. Pause it, listen to it, and listen to it again until you get it. And then once you get it, then perform it. All right, use the video to your advantage. All right, so here we go. So we're going to take this. Whoa, that's a little bit too dark. Let's go. You want your lines thin. All right. So draw them thin. The reason why is you want to be accurate. All right, so you're going to take your compass here and put it off to the side, and I just located root 2. So the distance from A to B is root 2. When you construct an arc going down to the number line, wherever it intersects the number line is the square root of 2. So now, let's call that point, I don't know, let's call it point D, let's say. Okay, so from A to D is the square root of 2. Once I know that, then I can get other things. I can get all kinds of things. I can get the square root of 3. I can get all kinds of things. Square root of 5. I can really use this to my advantage. So once I know the square root of 2, by the way, what's the square root of 2? As a decimal, that is. What is that approximately equal to? Let's go to the calculator here. Now let's take the square root of 2. And we notice that it's 1.414. So 1.414. And that's obviously less than 1.5. And that's obviously less than 2. All right, so notice that it's less than 1.5 units. It's not quite halfway between 1 and 2. So I know I'm right. I mean, I know I'm accurate. And you should, when you do constructions here, guys, you have to determine if you're accurate or not. You got to use your common sense. And that's part of MRWC, is that we're making sense of our numbers. We're not just doing things like we do in typical math classes. We actually tried to understand in a deeper fashion what it means to be irrational, what it means to be the square root of 2. Why is it 1.4? Well, guess what? We just constructed it, and we're less than 1.5 units on the number line. So I did it with a compass and a straight edge, for God's sake. You know, I just showed you that it's less than 1.5 units. So the calculator answer makes sense with the construction. So it makes sense. All right. Now let's make more sense. Okay, so here we go. Root 8 is 2 root 2. I talked about that earlier. Okay, so I talked about this, and I performed it over here. Oh, I got a little crazy right there. Yeah, that's a little bit better. And once I got 2 root 2, I'm trying to construct 2 root 2 minus 2. All right, so let's figure out how to do that. All right, so what we're going to do is we're going to construct 2 times root 2. Okay, so how do we do that? Well, believe it or not, we do it with our handy dandy compass. All right, we do it the way the Greeks did it thousands of years before Christ. I'm talking about 2,000 years before Christ. That's why this stuff's so amazing. I mean, I find mathematics amazing. I find just history amazing. The Greek civilization, the Greeks were amazing. And if you haven't researched, if you haven't researched the Greeks, I'm talking about the Pythagorean days, Pythagoras days. I'm talking about 2,000 years before Christ. You should. Okay, research Pythagoras. We talked about this in my last lesson. Pythagoras. There we go. Research that guy. This guy was not only the most famous guy, but he and a bunch of other dudes were super smart, and they studied geometry and other forms of mathematics, and they were the best in the world. Take a look at it. Okay, so let's get back to our example though. How do we get the square root of 8 minus 2? Well, square root of 8, as I just talked about earlier, okay, is the same thing as 2 root 2. So you adjust your compass from A to D, which is 2 root 2, excuse me, root 2. All right, and then watch this. Watch closely now. Watch, 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 watch. Okay, you're not watching. Watch. Okay, I'm going to move it over to D, and I'm going to construct an arc. Okay, that's too thick, so let me try it again. Now, you always want to make your arcs and lines very thin. Okay, so mark off. So you first adjust it from A to D, and then from D to the next point is root 2 again. All right, so let's just shift it off, and now this right here, I apologize for this. On my computer defaults to like some super thick lines. Okay, so from this distance here, let's call this point E, let's say. Okay, that's the square root of 2 again. Okay, so root 2 plus root 2, guess what? Is 2 root 2. Okay, 2 root 2. So E is 2 root 2. Whoops. 2 root 2. 1 root 2 plus 1 root 2 is 2 root 2. Oh my God, we're doing some serious math here. Okay, so E is at 2 root 2. And now I have to get, 2 root 2 minus 2. Okay. So we have to subtract 2. So that means we have to go 2 units back to the left. So if we have to subtract 2 units, we got to go to the left 2 units. Okay, well that's easy to do. All right, with a compass, right? You do everything the way the Greeks did it back in the day. I mean, if a civilization that was like, say, that's 4,000 years old, if they can figure it out, so can we. All right, I mean, come on, we're supposed to be the smartest civilization on the planet. I'm not sure about that, but if we're supposed to be, then we can figure this out. All right, so adjust your compass from A to C, 1 unit. Okay, now come back over here. Now we want to take 2 root 2 minus 2. So switch hands and mark off 1 unit. So we want to go 1 unit to the left. So we got to subtract 1 unit, right? That's what I just said. 1 unit to the left. So we got to subtract 1 unit. So right here, at this point right here, that's 2 root 2 minus 1. Let me make a note of that. 2 root 2 minus 1. I want 2 root 2 minus 2. So I got to go back to the left. When I say, oops, I didn't mean to do that. Sorry. I was stretching right there. Oh, I didn't mean to do that to you. You got to be careful with the compass. Let me just make sure it's adjusted to 1 unit. Okay. There we go. All right, so I was getting a little crazy right there because again, it's my birthday, so hey, I'm allowed to be a little crazy. So right there, we went 1 unit back to the left. When I say back to the left, I meant to the left. Now you got to subtract 2, so now you got to go obviously to the left 1 more unit. And so mark it, construct that arc. See, look at the compass. It is a video, so if you want to watch it again, hit the rewind button. All right, so right there, right where the arc hits the line, right there is it, okay? And that, my friends, is 2 root 2 minus 2. So we go back one more unit, go left one unit, and now we're at 2 root 2 minus 2. There's the end result. Now, notice that I said in the beginning that 2 root 2 minus 8, or root 8 minus 2, excuse me, I didn't say that correctly, 2 root 2 minus 2, or root 8 minus 2, we should get this decimal 0.82, which is less than 1. And notice that I ended up at a point or a position that's less than 1. Okay, so your constructions have to make sense. It's very, very important that you do things that make sense. Okay, so let me even write that out. So your constructions must make sense. And if they don't, then you obviously made a mistake. All right, so I should end up left of 1 because 0.828 is less than 1. So if you didn't do that, well, then guess what? You didn't do it correctly. So you got to be accurate. Accuracy is important. I grade upon accuracy, so you practice until you get it right. Okay, so there we go. That's just a lead in to activity 3B1, and then it's up to you to figure out the rest. All right, you obviously have to simplify the roots. Like in the number 2, you have to simplify root 18. You should know how to do that. If you don't, well, then you better see me on the side, because that's a prerequisite skill. And then you go through the entire activity. All right, so your job on the next one is to construct root 18 minus 3 in a similar fashion that I did. The next one, you got to simplify root of 32 and then subtract 4, and you got to do it in a similar fashion. Okay, and then number 2, you got to construct root 12, which means you got to simplify it first. Okay, that's a first right there. So the square root of 12 is equal to what? You got to figure out the factors of 12. So you got to, take 12 and factor it. So, divide 12 by 2 to get 6, divide by 2 to get 3, divide by 3 to get 3, to get 1. And then you get your factors. You got to factor this and simplify it and then construct it. Okay? And then on the next one here, you got to do something new. You got to construct root 7 and then root 5 and then add them on the number line and figure out where it's located. Where is root 7 plus root 5? Where is it located? And how does that compare to root 12? I don't know. You got to figure that out. So, and then you got to go back to our previous discussions. How do you construct root 7? How do you construct root 5? Go back to the previous discussions. We talked about that. And then you can answer the following question once you construct it. And then on the next one here, you got to construct root 3, which I already talked about, and root 2, which I already talked about, and then construct the difference. Okay, constructing the difference means you just subtract root 2 units to the left. And then after you do that, you can answer the following questions. So you got to do some homework first. The constructions are important in MRWC because they help you realize the algebraic properties that we talk about in the lessons, in future lessons, and also in algebra and other courses. Okay, so the constructions are not just for fun. They're to help you realize where the number is on the number line. They're there to help you realize that whether it's either legal or illegal to either add roots or multiply roots or subtract roots. I mean, we'll have that discussion after you finish the activity and after you, obviously construct everything and realize certain things. So you got to put it in your heart and soul on this. We're going to take a look at the results and we'll have a good discussion when I see you after this. So again, this is Mr. Ainsworth, and I'll see you in my next lesson. All right, good luck. Work hard. See you. Bye-bye.